Hey you guys, it is Kaylin and Cletus here, and today we're going to talk about factoring. So far in Chapter 9, we've been multiplying polynomials together, and today we're going to be going backwards and essentially figuring out what was it that I started with multiplying so that I now have this polynomial. So factoring is basically dividing, figuring out what's the factors of that polynomial. So we're going to start, so there's three different types, okay, that we're going to talk about in this section. And I'm going to split those three different types into three different videos. So let's talk about the first type, just in basic factoring. So let's talk about elementary school. So in elementary school, you learn to factor. You talked about factors and multiples. So if I want to find the factors of 6, or if I was asked to factor 6, I would say that 3 times 2 multiply to give me 6. So 3 and 2 are the factors. Now, if I wanted to talk about the greatest common factors, then I would say, what is a factor of 6, 15, and 30 that they all share, okay, and the biggest of that? So 6, 15, and 30 all share a common factor of 3. There's no other one that they share, but it's also the greatest common factor. So in 9.2, in the first part, we learned something like this. So we had a monomial and we were multiplying it by some type of polynomial. Either it was a trinomial or a binomial, and then essentially this would have been our answer. Okay, so this would have been our final answer. Now we're going backwards. Okay, we're reversing it when we're factoring. So what I want to do with this is I want to figure out what's the greatest common factor. That was essentially what the monomial was. So what is the greatest common factor of 8, 4, and 12? I like to start with the numbers first. Well, 4 is the greatest one that goes into all of them. Then I like to look at the variables. So d cubed, d squared, and d, I can pull out a d. Okay, and it might make a little bit more sense when we put in here what I'm multiplying by. There's 3 terms, which means using the distributive property, I also have to put 3 terms. And you know what? I know it's going to be plus, but let's not put that in just yet. So then I want to say 4d times what gives me 8d cubed? 4 times 2, d times d squared gives me back my 8d cubed. All right, second term, 4d times a positive d, so I know that's a plus d, gives me back a 4d squared. All right, last one, 4 times a positive 3 gives me 12, and then I'm not going to tag on anything else because 4d times 3 gives me a 12d. So those are my factors for number 1. For number 2, I have 2 terms that I'm going to get back. So I'm going to put a little like blank here saying I got 2 terms I got to get back. The greatest common factor of 3 and 6 is 3. And I also got to bring along a c because I can factor out a c from each of them. 3c times a positive 2c gives me back 6c squared. 3c minus 1 gives me back a negative 3c. So let's talk about why. Like, what would be the point of factoring? I'm just going to give one example, but there's lots of them. So one thing is, what if, for example, I had the fraction 3c over 6c squared minus 3c? Well, this would let me know by factoring. So we factored this out, and we got 3c times 2c minus 1. By factoring, this tells me I can cancel these out. So just like if I had any type of fraction, factoring helps me cancel out common factors to get it in simplest form. Or I could also use it for finding a least common denominator when I'm adding or subtracting fractions. And you can also add or subtract polynomials. Here's the other thing it does. We know we cannot take a number and divide by 0. So essentially what we're saying is that this cannot be equal to 0. So I know that if I stuck in c equals to a half, this would make this equal to 0. So by doing this, I also know that c could be all real numbers, but it cannot be equal to a half. All right, so thanks for listening to this type. We're going to go to the next video and talk about the next type of factoring.